Okay, so here we have our circuit again. Let's take a look at this guy. And I have a voltmeter or oscope probe. I'm hooking it to my oscope over here, so I just want to look at the waveform. So I was talking about how nonlinear this waveform is. Here's our little dial thing. I'm going to dial that up and down. And I actually put an extra mega ohm or 10 mega ohm resistor in series with it, with the probe, so we can divide the voltage down because it's actually too high of a voltage to go in as 10x. And let's just turn it on. And here's what our waveform looks like. And it's not triggering yet, and it's actually, let's get it triggering. So it goes through this nonlinear process. It's very, very spiky. When I turn it back down all the way, it's got these spiky things. So for some reason, when it first starts out, it's not triggering the same way. It has some kind of hysteresis or something. But you can see how it chops the voltage up and down. And when you turn the dial, you can make it get bigger and smaller. I'm going to go off scale because I'm still not dividing it down enough. But look at all this spiky stuff on here. So that's what we're dealing with when we got to filter the circuit to make it into a usable DC power supply. That's why we need all this high power resistors and such. So anyway, let's look at the improvements that we need to make this circuit work right. Okay, so actually I'm going to do a part 2 to my simple DC variable power supply, because I found an improvement on it, and I've already done a lot of the details in the first video. But what I ended up doing is changing the circuit, and let's take a look over here. So here's our circuit, and I added in another resistor here, about 100 ohms. Okay, so about 100 ohms, and so this is a circuit that we originally had. And we have what we're doing is using a rheostat, which has some kind of SCR that triggers and produces this really spiky waveform, which is really hard to use, especially if you want to turn it into a DC power supply. And I'm rectifying it with a full wave bridge. And I found out that you had to put a resistor in shunt with the capacitor, which is wasteful. But what that does is that causes the voltage to bleed down, because it produces all these tiny little spikes that are at full voltage, so it'll eventually charge up your capacitor to high voltage, even if you're drawing a power supply off of it, unless you draw a lot of current. And so if you want to start out at low voltage for your projects, it's not going to do it. It's going to basically blast them with full voltage. But I found that the range wasn't going all the way down to 0 like what I wanted. It was just going from like 60 to 120, so it was variable, but not as variable as what I like. And I found if I put a resistor right here, and so this resistor is around 100 ohms, and you might want to play with this. And this one was around 500 ohms, but maybe different values will give you better results. And this gives a more full range. It brings the voltage down even more by limiting the power from our rectifiers into the capacitor. So this is a limiting resistor there, and that's that resistor right there. And there's our shunt resistor right there, and our capacitor. And here's our rheostat. And now there's our full wave bridge rectifier. Okay. And so let's take a look as we vary the voltage. So I'm going to twist the knob over here. I'm not going to move it around too much because all the wires need to be taped up, and I don't want to short this thing out. Well, it's plugged into 110 because that could be really terrible. Okay. And so with this configuration, it goes down to about 16 volts. And it has a nice transition, completely variable, 30, 20, 30, 45, 80, 90, 100, 111. And so all I'm doing is just turning this knob down here, and it's changing the voltage smoothly all the way down to it's almost 17 volts, but it's a lot better than before, because before the lowest voltage was 60 volts, and it's real easy to damage stuff at that level. Around 10 volts is, or 16 volts should be fine. So anyway, let's take another look at our setup here. We'll zoom back out. And so the power is coming out. I'm measuring it across this resistor, but this resistor is in shunt with the capacitor. And there's our circuit. Anyway, very interesting power supply. I'm going to use it for some neat projects coming up, but just thought you guys would appreciate that. This is Dr. Janes, and thanks for watching.